Imagine a kitchen with no refrigerator hum, no freezer drawer, no plastic wrap sealing anything tight, just a table, a few clay jars, and food that has one job: survive long enough to be eaten. Now, picture a piece of meat on that table. In a modern home, you'd worry about hours. In the old world, people needed weeks, sometimes months. And they did it with something so ordinary, you barely notice it today: a pinch of salt. Here's the question hiding in plain sight. When salt preserves food, is it killing bacteria, or is it stealing something even more fundamental? Let's get into it right here on Secrets of Simple Things. Before cold, people traveled with food. Before cold storage, food wasn't just something you ate, it was something you carried. If you were a sailor crossing open water, you couldn't depend on fresh meat. If you were a trader moving between towns, you couldn't stop every day to hunt and cook from scratch. If winter was coming, you couldn't gamble on luck. So people built diets around foods that could move: salted fish packed into barrels, cured meats hung to dry, vegetables preserved in crocks, fermented sauces that stayed stable while the world changed around them. These were not recipes at first, they were strategies. And slowly, those strategies became culture. The flavors of whole regions, what tastes normal, what feels comforting, what counts as a proper meal, were shaped by the simple fact that some foods could endure time and distance. To understand why salt did this so well, we need to understand what spoiling actually is. Because food doesn't rot by itself, it gets taken over. Food doesn't rot, it gets eaten. When we say food has gone bad, we often imagine it like rust on metal, something that happens naturally, quietly, inevitably. But spoilage is not passive, it's a living process. Bacteria, molds, and yeasts are everywhere. They float through the air, settle on surfaces, cling to our hands, and already exist on many foods before we even touch them. Most of the time, they're harmless in small numbers. The problem begins when conditions are right. Give microbes warmth, moisture, and nutrients, and they multiply fast. As they grow, they release enzymes that break food down into easier-to-consume pieces. They leave behind waste. That's where the signals come from: sour smells, slime, discoloration, strange textures. Sometimes, depending on the organism in the food, they can also produce compounds that make us sick. But if you had to pick one factor that makes all of this possible, it isn't warmth, it isn't air, it's water. Microbes don't just like water. They require it to function. Water is the medium that lets their chemistry run. Remove their access to water, and their entire system starts collapsing. That is the real target of salt, not the food itself, not even the bacteria directly. The real target is moisture. The real target is water. Salt's preserving power comes down to one of the most basic forces in biology: osmosis. Osmosis is the movement of water across a membrane from where there is more available water to where there is less. Living cells are wrapped in membranes. Those membranes can let water pass. So when the environment outside a cell becomes much saltier than the inside, nature pushes toward balance. Now imagine a microbial cell sitting on a piece of food. Inside that cell is a watery environment because life needs water. But when you heavily salt the food, the outside becomes a high salt zone. In that moment, the cell is in a crisis. Water begins to move out of the cell to dilute the salty environment outside. The result is blunt and physical. The cell shrinks, it dehydrates. Its internal machinery can't operate the way it should. In many cases, it dies. In other cases, it becomes dormant, unable to grow or reproduce until conditions improve. This is why salt works, not because it poisons bacteria in some dramatic way, but because it bankrupts them. It takes away their most essential resource, water. And salt doesn't only pull water out of microbes, it also pulls water out of the food. When salt touches meat, fish, or vegetables, moisture inside the food begins migrating toward the surface. The surface becomes wetter at first, but that wetness is now salty. So you get a double barrier. Less water inside the food for microbes to use, and a hostile environment on the outside, where most spoilage organisms struggle to function. This is the core idea. Preservation is not a mystery, it is water control. And once you understand that, you start noticing why salted foods don't just last longer. They feel different in your mouth, they look different, they behave differently in the pan. Why salted food feels different. Pick up a fresh piece of meat and then pick up a cured one. Even before you taste it, you can sense the difference. Salted foods often feel firmer, denser, sometimes slightly darker. That's not magic, that's physics and structure. As water leaves, the food becomes more compact. Flavors concentrate because there's less dilution. In meat, salt can also influence proteins in ways that change texture, helping certain cured foods slice cleanly instead of falling apart. In vegetables, salting can soften cell walls just enough to change crunch, while still protecting the food from rapid decay. So salt preservation is not just keeping food safe. It is reshaping the food into something built for time. And from that one principle, control water humans developed two main paths. One is dry, one is wet. They use the same science, but they lead to different results. Dry salting vs. brining. The oldest method is dry salting, rubbing salt directly onto food or packing food in layers of salt. With dry salting, the food starts releasing moisture. That moisture dissolves the salt. Over time, the food essentially creates its own liquid environment, a natural brine forming right on the surface. This is why traditional salted fish and many cured meats feel so concentrated. The process is aggressive. It pulls water out quickly, and it creates an exterior zone where most microbes cannot thrive. This method is practical. Salt is portable. You don't need a container full of water. You can preserve large amounts of food with simple tools. That's one reason it traveled so well through history on ships, on long routes, in places where resources were limited. Brining, on the other hand, is salt dissolved in water first. Food is submerged in a controlled salty solution, and salt slowly penetrates inward. Brining is gentler. Because the food is surrounded by liquid, the moisture loss can be more balanced. The food can end up with a different texture, often less dry, sometimes more tender. That's why brining shows up in pickles and certain cured meats. It preserves, but it can also protect juiciness. Same principle. Different feel. Dry salting tends to push toward firmness and concentration. Brining tends to push toward penetration and balance. So if salt is this powerful, a reasonable question follows. Why didn't it solve spoilage forever? Why do salted foods still have limits? Salt has limits. Salt is an extraordinary barrier, but it is not an absolute one. Not all microorganisms respond to salt the same way. Most spoilage bacteria struggle in high salt environments. Their cells dehydrate. Their growth slows dramatically. Many simply stop. This is why salting can buy time so effectively, and why it became one of humanity's earliest survival tools. But some microbes are adapted to salt. Certain organisms, often called halophiles, can tolerate salty conditions that would cripple others. They won't dominate every salted food, but their existence explains something important. Salt is not a universal off switch. That's why, historically, salt was often paired with other preservation methods. Drying reduces water even further, leaving almost nothing for microbes to use. Smoking adds chemical compounds and creates an additional hostile surface. And fermentation changes the environment entirely, often by increasing acidity. In other words, salt is a powerful first wall, but in many real-world traditions, it was part of a system of walls. And here is the twist that makes salt even more interesting. Sometimes, salt isn't trying to stop all microbes. Sometimes, it's trying to choose which microbes get to stay. Salt doesn't always kill. Sometimes, it selects. Think about fermentation foods like sauerkraut, kimchi, or many traditional pickles. These foods are alive in the beginning, and salt is what sets the rules. When you salt vegetables, you suppress many harmful and spoilage bacteria. They can't compete well in that environment. But certain beneficial microbes, especially lactic acid bacteria, can handle it. They survive, and then they begin to transform the food. They consume sugars naturally present in the vegetables and convert them into lactic acid. The acidity rises, the pH drops. And as that environment becomes more acidic, it becomes even harder for spoilage organisms to take over. So in fermentation, salt acts less like a weapon and more like a gatekeeper. It doesn't sterilize the food. It shapes the microbial community until the right microbes dominate, creating a stable, safe, flavorful result. This is why fermented foods can last for months, sometimes longer, without modern technology. The preservation isn't just dehydration, it's a controlled ecosystem. Salt opens the door for one kind of life so that another kind of life can't move in. And once you see that, salt stops being just seasoning. It becomes something else, an ancient technology that uses biology against itself. The 5-second rule. So how does salt preserve food? It doesn't win by force, it wins by economics. It makes water life's simplest fuel too expensive for most microbes to afford. Cells shrink. Growth stalls. Spoilage slows, not because time stopped, but because biology lost its easiest pathway. Here's the 5-second rule. Preservation is water control. And that single idea explains more than a kitchen trick. It explains why cured meats traveled, why fish could cross oceans, why vegetables could survive a winter, and why whole cuisines learned to taste complete without freshness. Salt was never just a flavor. It was an early form of infrastructure, portable, reliable, and small enough to fit in a pocket. We built refrigerators to move heat. Long before that, we used salt to move life itself away from our food and back into our hands. If you look at your salt shaker now, you're not looking at seasoning. You're looking at an ancient technology that still works. If this changed how you see salt, leave your answer in the comments. And if you enjoy stories hidden inside everyday things, consider subscribing.